When I was 7 years old, I saw a volcano erupt for the first time. It was Mount St. Helens in Washington state, just a few hours from where I grew up. And even though the eruption I witnessed was small compared to others that had happened there in the past, it changed my life forever. I remember staring at the tall ash cloud with the dark smoke billowing out of it, and thinking to myself, I want to understand how something so powerful and beautiful can be created. Fast forward to today, and I'm still trying to answer that very question. Hi everyone, I'm a volcanologist and educator. I earned my PhD from a university, and today I work as a research scientist at a science center where I develop and deliver educational programs about volcanoes and other cool earth science topics. So if you're anything like me, then chances are you have always been curious about how our planet works and what makes it so darn cool. And I think one of the best ways we can learn more about the world around us is through taking classes. In this series, we will cover everything you need to know to understand how volcanoes work, from plate tectonics to magma chambers to volcanic landforms, and much, much more. I will introduce you to the basic principles behind each topic and then show you how they apply to real volcanoes and eruptions. You won't need any background knowledge in geology or any other science. All you need to bring is an interest in learning and a willingness to ask questions. Now, I have to warn you, sometimes I get really excited while talking about volcanoes, and I have a tendency to ramble. So if you find yourself lost in a topic, feel free to pause the video and reflect on the key ideas until you feel you understand them fully. If you need more clarification, leave a comment below, and I will do my best to answer it. Also, since I make all of my courses available for free online, I encourage you to share your thoughts and insights with others in the comments. Learning is a social activity, and you might gain new insights from someone else's perspective. And finally, if you want to stay up to date on all things volcanoes, make sure to subscribe. Okay, let's jump right into Lesson 1. What is a volcano? To answer this seemingly simple question, we need to talk about the three main parts of a volcano: the magma, the conduit, and the volcano vent. Let's start with magma. Magma is molten rock found beneath the Earth's surface. Now you may be thinking, wait a second, didn't you say this was a beginner course? And yes, I did. But now I have to introduce you to one of the coolest things about geology, which is that the Earth's surface is broken into moving plates. These plates float on top of the semi-molten rock in the Earth's mantle, kind of like how a raft floats on water. The space between these plates is called the asthenosphere, and it's here where rocks can melt and turn into magma. But why would rocks melt in some places and not others? Well, it turns out that heat from the Earth's core actually seeps up through the mantle, but it does so faster in some places than others. In fact, heat can move so quickly through the asthenosphere that it melts the rock completely. When this happens, we call it a magma chamber. Okay, great. We now have magma, but where does it go? Well, that's where the second part of a volcano comes into play, the conduit. A conduit is basically a pipe that connects the magma chamber to the Earth's surface. Magma flows through the conduit and eventually reaches a spot on the Earth's surface called the volcano vent. A vent is simply an opening where gas and/or magma can escape from the conduit. And depending on the type of magma and how gas bubbles interact with it, different types of landforms can be built up over time. In fact, the cone-shaped landforms that we typically associate with volcanoes are called stratovolcanoes. Stratovolcanoes are formed by alternating layers of magma and tephra, which is a fancy term for fragmented rock. Each time fresh magma reaches the surface, it piles up around the vent and creates a new layer on top of the volcano. Over time, millions of years even, these layers build up to form a cone. But it's important to remember that not all volcanoes look like stratocones. Some volcanoes are made entirely of tephra and are known as cinder cones. Others are formed by large outpourings of liquid magma called lava. These are known as shield volcanoes. Regardless of shape, all volcanoes have three things in common. They all have a magma source, a conduit, and a vent or vents. By understanding how these three parts work together, we can begin to unravel some of the mysteries surrounding these powerful geological features. For example, Imagine that you're standing at the summit of a volcano looking down into the crater. The crater is basically the hole at the top of the volcano, and if you were standing on the side, you could see that the crater has steep walls. But why are the crater walls so steep? To answer this question, let's pretend that the magma inside the volcano is like honey, and the conduit is like a straw. If we put a straw inside a cup of honey and pull it out, we will see that the sides of the cup are a little bit steeper than the original angle of the walls. That's because the honey sticks to the sides of the cup and pulls itself up. In a similar way, the magma inside the volcano sticks to the walls of the conduit and pulls itself upward. This phenomenon is called viscous drag, and it's one of the main factors that determine the steepness of crater walls. The stickier the magma, the higher the angle of the crater walls. And when magma isn't runny, like the honey in our example, it tends to pile up around the vent, forming a mound. That's why many cinder cones have a very steep profile. In contrast, if the magma is runny, like water, it flows down the sides of the volcano, forming a wide, gently sloping profile. That's why shield volcanoes tend to be much larger than stratocones, but also much less steep. Let's take a moment to reflect on some of the key ideas from this lesson. First, volcanoes are made up of three main parts: the magma, the conduit, and the volcano vent. Second, the shape of a volcano depends on the type of magma it erupts. Runny magma produces shield volcanoes, whereas sticky magma produces stratovolcanoes and cinder cones. Finally, the angle of the crater walls is determined by the stickiness of the magma. The stickier the magma, the steeper the crater walls. Thanks for watching. I hope you enjoyed this first lesson in our mini-course. If you want to continue learning about volcanoes, make sure to check out the next video in the series. See you next time.